Hello everyone, welcome to my YouTube channel Data Partnership. My last video was Mumbai flood mapping using Google Earth Engine, where I have used SAR data, means synthetic aperture radar data from Sentinel-1. This video is basically what I used here is we have the Sentinel-1 data and for flood detection, and we also used JRC Global Surface Water for permanent water mass, population data for WorldPop, and for cropland exposure I have used ESA World Cover. Basically, is the land cover, right? And we have basically used the threshold or 0.75. So we have used this uh, this data for uh, latest image for 01/08/2026, and we have used pre-flood date is 27 and means 28th July 2026. So based on that we have done this analysis, right? So we have seen these images. So now this is my next video is basically this video mainly talks about this 8th July 2026 is the improved version of my earlier video. So what improvement I have done is that, of course, Sentinel data we have used, and we use the linear power, means this one is same orbit direction for before and after, and speckle reduction automatic Otsu threshold. Basically this one is the important. Basically it will automatically will take the threshold, right? Permanent water removal, and we have used slope masking and small patch removal also, and flood area calculation, expose population exposure, and cropland, right? So first it is we have used this coordinates for Mumbai. So you can use according to your area. So, so we have then used the Sentinel data. It is very simple as earlier, right? And then we have basically decided what are the dates we have to take. So this is similar to my previous one, and this is the this algorithm for the pre-flood image and before date and all. So we got this one right by writing this code. Then we have to click the image before and after, right? This is the simple thing. Uh, in this is the where before image and then before dot click. AOI means your area of interest, what we have um, uh, mentioned here, right? So now we have to, in my previous one, what we have used, that we have used threshold 0.75. So here it will take automatically, like we have to create a function for also, then it will take value from pixel value based on the uh, pixel value. It will take automatically the, this is the big lot of, it's a very big one, means lot of codes we have to write, right? So you just use this one and you can change the corrections based on your skills, basically. So you can a lot of things I have just copy pasted from Google and Chat GPT or Cloud A, because I didn't know about this. So I just tried to, I understood the whole phenomena, but I didn't do the coding, because just I copy paste from there. So how to use that, right? Then I just put it here. So then we have to calculate ratio histogram. After ratio histogram, we have to create the initial flood mass. So ratio we have taken from here, right? Basically, what also is going, it will the main objective of also is to to get calculate automatic threshold. That's why it's a so then we have to create the flood, then ratio dot lower than threshold. If it is lower than threshold, then we have a flood mass. Then we have to remove the permanent water because there are a lot of lakes and permanent water bodies around Mumbai. So then we have to remove them, otherwise it will show that also in flood pixels. So this is we have taken from global surface water. So we have to select the occurrence from that, and for to how to know about this, you just type this one as search, then you will get details about this this image where we have taken the occurrence. So this is flood. So permanent water we have removed, right? Then we have to get give the slope mass because slope and flooding have the big relation. So accordingly, because for the slope uh, I have already created videos on slope, so you please go through in my uh, related videos so that it will help you how to calculate the slope. I just stick to the this one dm for SRTM. Then we have calculated where slope equal to e dot terrain dot slope. Where we have given input is the dm. So if it is lower than 5, then it is the flat area basically. Otherwise, because if it is flat area, then different, and if it is slopey area, then it will be different. Means if it is mountainous, then we have different algorithm. So here, since it is we are talking about the flat, so slopey this flat area has the value. So then we have this removal and all. Then we will have the final flood map. So then we have calculations similar to earlier one. Then population exposure also from the earlier one. Once you this is the crop cover similar to my previous one, and you can check for your area. Then we have to do the flooded cropland area. So this is similar, and then we have to run the this whole script, right? It's a long one, so you just try. If you need this script, then please write on comment, so the and provide your email ID also. So I will provide you this whole code so that you can use in your for your project, right? So and you can improve it basically. So what we have done is that we have, you can see from here. So we have flooded cropland, you can see here this area, right? This area we may have this one. If you see uh, so satellite image uh, at the background, then you can see how it changes, right? Yeah. So if you see this one flood cropland, so this is the area where we will have the, okay, it's loading. So there may be possibility of cropping area, right? So if you see, if you come, yeah, you can see this yellow area as the cropping area. So you can see this area is also flooded. Yeah. So you can cross check this with the satellite image, right? If you see, I can see that, right? You see here, yeah. So there should be some cropping area. Yeah, maybe, right? So we have to check that, because it's a, so this we have to improve actually. It doesn't mean that all the time it will give you the crop, like you can see this one is it is showing this is the crop area, right? This is the airport area, it looks like, right? And here we have this area, it is showing that it is also cropland. So that's why this is where we need to do the corrections and all, because here what we have done is this land cover area we have directly used directly use this one where I have taken the uh, this one, this crop area, right? Land cover map. So what we have to do is then we have directly taken this one, right? This land cover map. So for better results, what we have to do is we have to do this land cover classification by our own, so that you can define the classes. Otherwise, this you can see some places here, like this is not the agricultural, this is not the cropland, right? So that's why it is giving the error. So because 2021 image, so here you can see uh, this area. Also, this is the residential area or built up area. So these kind of things we have to check actually before giving any conclusion. So that's why we should not use directly those codes and give the report. Of course, this is the process. Basically, my objective is to give you the process how to do that. The next thing is that you should go to my land use land cover mapping video, where I have created that from the satellite image. So then you what will have is that you will create your own classes. Means like if it is agriculture, then you will define that. If it is built up, then you will define that. So based on that, we will create our land cover map. Here, what we have done is that we have just taken the from the world cover map, because it's early 2021, so it may have some error. So that's why it is showing that it is the cropland, but in reality it is not. So that's why we need those checkups, right? So this is the flood map. You can see those areas flooded, right? And these are the permanent water bodies. As you can see, this is the, of course, this one is permanent bodies, right? So this body didn't detected this one, but most of the water bodies it has detected, right? This also we have taken from the one of the other data. So what we have to do is, then that's why I'm telling that if we classify the image, then it will take, you can see here, permanent, this one, what data we have used. We have used JRC data, right? So that's why I'm telling that if you Mm, if you create your own land use land cover map, then it will help you to uh, to define those and then do the analysis. So that will be the better. Uh, that is the better way to do the things, right? And but then you run this script, and it will. Um, what I will do is I will try to create a video for a smaller area, for Mumbai or some other places, where I will do my own uh, land use land cover mapping, so that this kind of error will not come for our study, right? So please subscribe my channel, so that you will get this kind of analysis, where we can discuss a lot of things, and it will help actually. The objective of this video is not to create to give a final report. This is the process what we have to adopt, right? For your area, the analysis will be different, and values will be different. So that's why I'm telling that the best thing is that to do, uh, d- means do the right thing, right? Of course, this is also not wrong, because we are using the open source data, so validation is required, right? If validation is required, then only you can say, okay, this is the flooding, like what happened here in this cropland, right? So we have to check these kind of thing before using data directly. Understood. So, this is the thing what I wanted to show you. Maybe some places it may show the cropland is correct, but you can see here, there may be a cropland, right? Yeah, here maybe this area is cropland or something like that, but it doesn't look the cropland area. So that's why this is the method you can use, but do some corrections, right? Thank you very much. Please subscribe my channel so that you will get this kind of videos, so that we can learn together. Thank you.